Welcome back, ladies and gentlemen. In this video, we'll look at building our mathematical toolkit. Specifically, we'll talk about scientific notation. Scientific notation has a general form where we have one digit in front of a decimal followed by other digits times 10 to the power of something. I'm just going to put a box around this and just kind of put a little arrow here. So usually we have one digit before the decimal. And the whole reason that we use scientific notation is to represent really big and really small numbers. Okay, now when I'm talking about really big and really small numbers, I'm really talking about things like the mass of the Earth. Now the mass of the Earth, if we were to write out that entire number, it would look something like this: 598 followed by 22 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And you kind of get where I'm going with this, is that, if I'm using the mass of the Earth in a calculation, I don't want to write out that many zeros. So we can short form that with scientific notation. And the way that I would write that big long number is to say 5.98 times 10 to the power of, in this case, 24. Okay. Now this times 10 to the power of 24, that's just telling us, hey, from 5.98, we've got a decimal location. And to really put it, if I wanted to write out all of these zeros, the 24 is just telling me to write this number out with all of its zeros. You would have to move the decimal place from where it is now at 5.98 and move it to the right 24 times. Okay, so the other sort of example with this is the mass of an electron. Now this is going to be a really small number. The mass of an electron, as you can imagine, it's tiny, and it's a constant number that we know and use in the world of science, and that number is 9.11 times 10 to the negative 31 kilograms. Now, we're writing really small numbers. Our sign on our exponent will just be a negative number, and that's just saying, hey, move the decimal to the left to represent a really small number. So this is my short form for decimal. So that's what the negative means in that exponent. Okay, so let's break that apart in a little more detail. Okay, first of all, on your calculator, you've got a calculator button that represents times 10 to the power of something. Okay, so scientific notation always has times 10 to the power of something. I'll just highlight that up here. It's always going to be times 10 to the power of something. So it's best that we go and find the calculator button that's on your calculator. Mine on my calculator is an EXP button, but it really just represents the same thing. It's times 10 to the power of something. Some calculators, their button is EE. You really should take a minute and just go and find yours, because it'll be an important button as we go through the course. Okay, so just a quick exponent reminder: 10 to the power of 4. If I were to write this out, that would be 10 times 10 times 10 times 10 4 times. And if you remember from Math 9, if we're multiplying by 10, we can really just look at this as being 1 with 4 followed by 4 zeros. So that's why we're always going to be multiplying by 10 to the power of something, because multiplying or dividing by 10 to the power of something is a fairly straightforward thing for us to do mathematically. Okay, another exponent law from Math 9, we have 10 to the power of negative 6. That's the same as doing 1 over a 1 with 6 zeros. Okay, and then if we were to do that calculation, we would just think of moving our decimal place from, on this 1, moving that to the left 6 times, because we are dividing by a 1 with 6 zeros. Okay, so if you imagine moving that decimal place from here to the left 6 times, so I don't want to make this too messy, but 1, 2, 3, 4, 5. You're moving it over to the left 6 times. You're going to end up with a number that looks like so. Okay, and I only mention that because as we get into our regular versus scientific notation, timesing by 10 to the power of something is, well, what scientific notation utilizes. Okay, so if we are going to look at a couple of examples here, if we convert this to regular notation, 4.38, if this exponent is positive, that means that it's representing a big number, and that's telling us that, hey, the direction that you should move your decimal place would be to the right to make this number 4.38, to make it bigger. Okay, so if I imagine starting here and going 1, 2, and then kind of keep going without me making a big mess of it, you'd end up with a number that looks like 438,000. Okay, so this is where the decimal place ends up after moving 5 times to the right. Okay, so on the other hand, if we have a really small number, which is represented with a negative on the power of 10. So that's just telling us, take this decimal, move it 4 places to the left. So if it's negative, you want to move left. Okay, so this number would become 0 point, and then we throw some zeros in here to give us some placeholders. 6, 4, 8. Okay. Okay, so going in the other direction, if we were to convert to scientific notation, okay, if our starting spot for our decimal place is here, okay, our ending spot is going to be over here because we only want 1 digit in front of our decimal. So I'm going to write down the numbers that I care about, and then I'm going to put times 10 to the power of, I just need to go and find out how many times do I have to move my decimal place to get from here over to the other arrow, which is 6 times. Okay. In a similar example, if this is our starting spot, we want to get it from, I guess, where it starts to where we want to put it in scientific notation. I'm going to write down the numbers that matter. And then because this is a very small number, my exponent will be negative on this times 10 to the power of 1, 2, 3, 4, 5, 6. Okay, so that's how we would convert those numbers. Okay, so when we get to using math with the scientific notation, you really just need to trust your calculator. Okay, so with these examples, what I would recommend that you do is try these questions for yourself. You can pause the video and give these questions a try. For this first one, I'll actually write out what I would type in my calculator. And usually what I'll do is I'll put boxes around the buttons that I would use on my calculator that are not numbers. Okay, so 2.4 times 10 to the power of 6 times 7.5 times 10 to the power of 8 should give you 1.8 times 10 to the, 1.8 times 10 to the 15. Okay, with the rest of these, like I said, I'll write the answers out, but please give them a try and make sure that you're, I guess, the order in which you're typing numbers is working out for you. Okay, this last one down here, this one's a little special, a little more difficult. So this is where we type 4.3 times 10 to the power of 2. And then we'd have to use our exponent button. And your exponent button might look like x to the power of y, or it might look like a little hat. Okay, so that's different than times 10 to the power of. So give that a try, and the answer that you should yield is 2.3 times 10 to the 15. Okay, and this last example on the bottom right of your page, if you plug that through and check out an answer, you should end up with 1.3 times 10 to the 22. Okay. Okay, that's a brief overview of scientific notation. There are some questions to try in your worksheet package. Please give those a try and come to class with any questions. Thanks very much, and we'll see you again soon.